The lengths of pregnancies in a small rural village are normally distributed with a mean of 265 days and a standard deviation of 16 days. A distribution of values is normal with a mean of 265 and a standard deviation of 16. What percentage of pregnancies last fewer than 281 days? Well, we're told that the distribution is normal. So that means the distribution forms a bell-shaped curve. So it might be a good idea to always sketch that out first and indicate the pertinent information. So the mean is 265 and the standard deviation is 16. So the mean is located right in the center of your distribution. It's good to just indicate that. 281 then is just something bigger than 265. And since you want the probability of pregnancies that last fewer than 281 days, we will shade to the left. Now, even though this says fewer than 281 days, don't be tempted to make the probability stop at 280. When it comes to normal distributions and continuous distributions, you could actually have 280.9 days, and that's perfectly reasonable in this situation. So there's no real great place to say what the value right before 281 is, because it's not on a discrete scale, it's on a continuous scale. So you just leave 281 as the input. And also the probability of 281 itself is 0. Anytime you do the probability of just a single point in a normal distribution, it's just 0. So don't try and change that. Use your calculator with the normal CDF function to come up with the probability. And it can take up to 4 inputs. The first 2 are the bounds of your shaded region, and this shaded region goes from -infinity, but there's no negative infinity button, so just you're going to use some number that's really small. And I tend to use -e to the 99th because that's a very small number. It's like 1 times 10 to the 99th. The upper bound of my shaded region is 281. Then I have a mean of 265 and a standard deviation of 16. So then I'll use my calculator to come up with this probability. So normal CDF is under the distributions menu. You hit second in vars. And negative second comma to get the E, 99, comma 281, 265, and 16. So that gives me 0.8413. Now, it's possible when you did that calculation that you saw a menu show up whenever you went to get the normal CDF function. And if that's the case, all this menu is doing is just asking you for what the value of those 4 inputs are, and allowing you to type them in a little bit more efficiently than separating a long list with commas. In the end, when you put your data in and you hit paste, it effectively pastes that information right into the normal CDF function, so you'll get the same answer either way. Now the final answer does request this to be a percentage rounded to 1 decimal, and you can take this 0.8413 and round it accordingly to the rules given, so you could write 84.1% as your final answer.